In this video, we're going to look at problems 13, 17, and 19 from your review packet. So let's jump in and take a look at problem 13. So problem 13, if we look at this, what they're asking us to do is find the measure of yx. So let's trace that out so we know what our end goal is here. We want to find the measure of that arc. Now all we know is that that arc is 31x. We also know though that this arc over here is 35x minus 16. Now if we look at those two, they kind of look congruent, but we don't want to assume that they are. So we need to find a property that'll tell us that they're congruent. So if we look over here, those two arcs are formed by these two chords. So if those chords were congruent, we would know then that our arcs would have to be congruent. So we don't know those chords are congruent yet though. So what we have to do is see, can we find a reason for those chords to be congruent? So we look at this and we find that the distance from center is the same for both of those chords. And if the distance from center is the same, what that means is that these chords are congruent, which then would tell us that these arcs are congruent. So now we know for sure those arcs are congruent, so all we have to do is set them equal to each other. So our equation is going to look like this. 31x is going to be set equal to 35x minus 16. And then we just solve from there. So what I would do is subtract the 31x from both sides. And you get 0 is equal to 4x minus 16. Add the 16. Get 4x equals 16. And then divide by 4. And you will get x is equal to 4 as your final answer. And that's it. So the next problem we're going to look at is problem 17 from the review. So this problem is a word problem, so we got to take a second to read it here. It says a chord in a circle is 18 centimeters long. So real quick, let's draw ourselves a nice circle here. So in this circle, it says that we have a chord that is 18 centimeters long. So 18 centimeter long chord there. So let's write 18 right there. Mark the center of our circle, say it's about there. And it says, and this chord is 5 centimeters from the center of the circle. So this line, let's do in a different color, is 5 centimeters from the center of the circle. How long is the radius of the circle? All right, so if we're talking about 5 centimeters, we know that's a perpendicular distance there. And if the radius is perpendicular to a chord, what that means is the chord is to cut into 2 equal parts. So this part of the chord here is going to be 9 centimeters. Now they want us to find the radius. So the radius would be from the center to a point on the circle. And so what I'm going to do is I'm going to draw my radius right here to make myself a nice convenient right triangle out of the 2 orange lines and the radius, the blue line. So that is my unknown. So from here to find the radius, all we're going to do, we've created a right triangle, Pythagorean theorem. So we're going to say 5 squared plus 9 squared is equal to my radius, which we called x squared. So we solve this, square your 5, you get 25. Square your 9, you get 81. And square your x, that just stays x squared. So we add these ones up, and we should get 106 is equal to x squared. And we get a final answer of x is equal to 10.296 centimeters. Then it specify what place to round to. So then it's specified I would go second or third decimal place. Okay, and the last problem we need to look at is problem number 19 for this video. And in this one, it's asking a question, is AB tangent to the circle, why or why not? So first, let's talk about what it means for a line to be tangent. So for this line to be tangent, it would need to touch the circle at one point, and then when a line is tangent, it has to be perpendicular to the radius. So this line must be tangent because it tells us that it's perpendicular by showing us that it's a right angle, and then it looks like it touches at one point, so it must be a tangent line. So we'll say yes, it is, yes, because it is perpendicular, and we're going to use the symbol for perpendicular here, perpendicular to the radius. Now, just as a second example, I'd like to look over here at problem 20. So this one, same type of question, is it AB tangent, why or why not? Well, it doesn't really tell us if it's tangent. It doesn't show this as a 90-degree angle. So what we have to do is we have to check to see if it is 90 degrees. And the way we do that is we're going to use the Pythagorean theorem. And if the Pythagorean theorem works, that means that ABC, this triangle here, is a right triangle, and therefore that must be a right angle. So let's check it out. What we'll have to say is that 8 squared plus 16 squared is equal to 19 squared. So we do some math here, put in calculator. 8 squared is going to be 64. 16 squared is, 256. And then 19 squared is 361. So we'll add those two together. If we add 64 and 256, we're going to get 320. And then it says that's equal to 361. Well, that's not true. So what we can say is no, AB is not tangent because it is not perpendicular to the radius. And that's it. Okay, so that was a nice little review of tangent lines and some explanation type problems that you may have to do on your test.